Hey guys, so in this video we're going to be going over transfer functions for RLC circuits with DC sources. And so at first glance, this circuit looks like it's going to be very hard to solve. We have inductors, capacitors, and resistors. And as we all know, inductors and capacitors are both governed by differential equations. So for the voltage across an inductor, we have VL is equal to L di over dt. And then for capacitors, we have I equals C dV dt. Okay, so it looks like we're going to have a big differential equation and we're going to have to solve for it. Some of you guys may be thinking about taking this differential equation into the frequency domain and solving, which would make our lives easier, but we can simplify even further. And why? It's because we have a DC source. If we had AC sources or more complex type signals as input, yes, we'd have to pay attention to these differential equations. But with the DC source, capacitors just become broken wires and inductors become shorts. So we can really simplify this circuit down to this. All right, so we have our DC source, 5 volts. Inductors become straight wires, so I'm just going to draw a straight wire. Capacitors become broken wires. So this inductor also becomes a straight wire, and then this capacitor also becomes a broken wire. So then we just have a resistor. And these facts should be apparent to you after taking an E&M class. You guys should remember that for DC sources at steady state, capacitors act like broken wires and inductors act like shorts. So if you guys don't remember that, just go brush up on a little bit of your E&M stuff just to understand why that's the case. So really, we just have a circuit that looks like this, and we can simplify it down further to just this. So over 5 volts, 1 ohm resistor, and this is the V out we want to find. And so it turns out that's really easy. V out is just equal to 5 volts. Now, I also modeled this circuit in SPICE to show you why the method I did is both good and bad. So let me bring up the diagram. And as you can see here, I'm measuring the resistance here. And so we have our 5 volt source, all our 1 ohm inductor or 1 Henry inductors and 1 farad capacitors, and our 1 ohm resistor. But as you can see here, we are not measuring 5 volts. We are measuring very close to 5 volts, but not exactly. And I think this has to do with some of the real world properties of inductors and capacitors. At least in theory, these should be acting as pure broken wires and pure shorts. But that's not really the case in the real world, and LT SPICE is taking this into account. So when we actually measure the voltage, we get something slightly different. So that's both the good and bad thing about this method. I made some assumptions which made the problem much easier, but the assumptions do not take into account everything, and that's why we get a different voltage out when we model it in SPICE. So anyway, that's an important thing to remember. If you have DC sources with RLC circuits, we can simplify a lot. You do not need to be using your differential equations knowledge in order to solve. Anyway, I hope this video helped, and I'll see you in the next one.